Hi everyone, we're going to dive into lesson 9.1, which is about solving quadratic equations using graphs and tables. What I'm going to do this time is something a little different. I'm going to lead you through the lesson by using our online textbook, which you actually also have access to. If you're interested in finding this on your own screen, you're welcome to shoot me an email, and I'd be happy to show you how to do it. First, let's just start off with where we're headed. We're going to look at how can graphs and tables help you solve quadratic equations. So quadratic equations are going to be those involving an x squared term, and we're going to look at solving them by, say, setting them equal to 0 and trying to find the values that work for them. Some vocab we're going to want to know about. First, quadratic equation. Well, an equation is quadratic when the power on x is 2, and that's the highest power we see. And then the zeros of a function, we're going to talk about that soon. The zeros of a function are actually the same as the x-intercepts. Not worried about the state standards. By the end of this lesson, I want you to be able to use graphs and tables to find solutions of quadratic equations. So we're going to focus a lot on Desmos. We're not going to use the calculator much because I'm not sure if all of you still have calculators. We're going to mostly focus on Desmos and doing tables on Desmos. All right, so to start us off, we're going to start with this first section called Explore and Reason. We're going to look at a problem that they pose. It says the path of a golf ball hit from the ground resembles the shape of a parabola. You can see where the golf ball hits where the club hits the ball, and then how far it travels all the way 200 yards down on the green. It says what point represents the golf ball before it is hit off the ground. That's this point right here, which is the origin. So I'm going to type in 0, 0 there. Okay. That's the point where the thing starts. What point represents the golf ball when it lands on the ground? Well, if we go all the way along here on the x-axis, it ends up being 200 units down or 200 yards down. So I'm going to type in 200, 0 for that one. Those 2 points are actually both x-intercepts of this parabola. Question C says, explain how the points in part A and B are related to the ball's distance from the ground. At each of those points, the ball is on the ground, which means its height is 0. Notice how in the first case that y-coordinate is 0, and in the second case the y-coordinate is also 0. We're going to look at a little bit more detail on how where parabolas hit the x-axis. That's the point of this lesson. All right, for our first example, we're going to take a look at this question. Why are the x-intercepts of the graph of a quadratic function important to the solution of the related equation? So the goal here is to find the solutions to this quadratic equation, x squared minus 16 equals 0. Okay, so what we're going to do to accomplish this is we're actually going to look through the solution that they do for us, and we'll talk about how that might look on Desmos for us as well. You might even know already what's a possible solution here. 4 is a possible solution, right? 4 squared is 16. 16 minus 16 is 0. That would work out. Let's take a look at their solution. First, they say a quadratic equation is an equation in the second degree. See how this has an x squared? We know it's quadratic. The related function of a quadratic equation with 0 on one side is the quadratic expression given on the other side. That's this thing, x squared minus 16. We're going to graph the function, so that's x squared minus 16. And what they show is that the two solutions are where that graph crosses the x-axis. So it says the x-intercepts occur here at 4 and here at -4. If we were to do that on Desmos, let's take a look at Desmos. And you guys could do this as well on your calculator or on your screen with Desmos as well. So x squared minus 16, there it is. And you can see that it crosses right there at -4 and right there at 4, right? Those are the two places where it crosses the x-axis. Our two solutions, therefore, are 4 and -4, okay? Finishing up their solution, the graph of the function has two x-intercepts. They are 4 and -4 as our two solutions. So when you're asked to solve a quadratic equation, you're really asked to find where does that function cross the x-axis, provided the equation is set equal to 0. And that defines one of these terms that we're concerned about. It says here that the zeros of the function are when the graph crosses the x-axis. Those are the zeros. All right, let's try another problem similar to this one. We'll do this one by ourselves, though. So find the solutions of x squared minus 14x plus 49 equals 0. I'm going to go over to Desmos, and I'm going to go x squared minus 14x plus 49. We're just going to graph the function. And we see that this function crosses right there at 7, 0. So I'm actually going to plot the point 7, 0 to show you guys that that's where it is. We're going to label it. Okay, there it is. 7, 0 is where it crosses. That means that the only solution to this equation is 7. 7 is the solution. That's where the parabola crosses. If we were to carry out their work, they do the exact same work, and they show us that x equals 7 is the solution. Let's look at another example. X squared plus 3x plus 7 equals 0. So I'm going to plot that, x squared plus 3x plus 7. And we're interested in when does this thing equal 0? Well, we can see that this thing never crosses the x-axis, which means this equation has no solutions. And we would see that back in their solution as well. There's the parabola, no real solutions. That's the thing we're interested in. The last couple, we're going to try these now on our own. X squared minus 36 equals 0. Ideally, if you could pause the video right here and try these two on your own, try graphing them on decimals and finding the solution, that'd be awesome. And I'll be right back with you to show you my solutions. Okay, hopefully you tried them. The solutions for 1A here are 6 and negative 6. And the solution for B would be negative 3. You can find each of those on decimals, right? If we graph on this one, the function f of x equals x squared minus 36, we see it crosses at 6 and negative 6. And if we graph the other one, it's x squared plus 6x plus 9, and that one only touches at negative 3 right there. Okay, let's go on to the next example. The next set is to learn how to solve quadratic equations using tables. So now this time, instead of using a graph, we're going to look at an input-output table for this function. We'll go through one example with them. Okay, so enter the function to a graphing calculator. Because we don't have a calculator available to us, at least I'm not sure if you do, I'm going to do this on decimals. So I'm going to go and do the function on here. I'm going to do f of x equals x squared minus 7x plus 6. All right, well, we actually can already see the solution. The solution is 1 and 6. We can see that on the screen. But I'm going to create a table as well. I'm going to click Add Table, and I'm going to just do a bunch of values. I'm going to go like negative 1, 0, 1, 2, 3, 4. And over here, I'm going to type f of x. I have to do f of x1 because that's what this is doing. What this is now showing us is it's showing us all the points on this parabola. They're actually showing up in red, that they're showing us the input-output pairs. So notice that it crosses the x-axis at 1 because 1 is paired with 0. And it also, if we were to continue this table down, say I go down to 5, say I go down to 6, it shows us the other place where it crosses the x-axis. So when we try to solve an equation, we're looking for when is the output 0. That happens at this point, 1, and at this point, 6. Next example, how can we use a table to solve this one? 3x squared plus 5x minus 2. Generating the table, I'm going to go over to decimals and generate the table this time. So we've got the function 3x squared plus 5x minus 2, and then I'm going to add a table. We can see the graph, of course, side by side. I'm going to go, say, negative 3, negative 2, negative 1, 0. We'll just keep going down the line like that. And then over here, we're going to take a look at f of x. Gives us the input-output pair. So where does this thing equal 0? It's 0 once at negative 2. There's our one solution. See where it crosses the x-axis. And it's 0 again somewhere in here, somewhere that's like after 0. Notice how it goes from being negative 2 to positive 6. That means it must be crossing the x-axis somewhere there. So we'd have to actually drill down a little further. We'd have to find where is that point in between there. If we click on there, it actually is going to show us. This is what's cool about decimals, is it shows us that 1/3 is the other place where it crosses the axis. All right, last problem. Let's have you try this one on your own. Try and generate a table. Pause the video and try it, please. Okay, hopefully you actually did the work. Let's go and use a table for this one. So we are going to try now 4x squared plus 3x minus 7, plus 3x minus 7. And if we've created a table, great. If you did it, we can add a table on here and find a whole bunch of values. If I start at negative 2, negative 1, and decimals actually adds them for us, which is really nice. See that one of the zeros is 1, right? Because it crosses at 1. Now it also crosses right there. That value doesn't show up in the table. That value is negative 1 point, let's see, where is it? Negative 1.75. We'd really have to drill down and see, noticing how at negative 2, it's 3. but at -1, it's -6. So it must have crossed the x-axis somewhere between there, which we see that it does. Okay, example 3, the next part of the lesson here. Let's go on to the next slide. It says, Anastasia hits her golf ball off the tee. The height of the golf ball is modeled by this function, where x is the number of seconds after the golf ball is hit. How long is the golf ball in the air? So let's take a look at the solution that they provide. First, we graph the function. You could do this on Desmos or a calculator. We want to find when y equals 0. That's because when y equals 0 is when the height equals 0. So we're going to find that it's going to hit a little bit after 5. It shows that the golf ball is in the air for 5 seconds. If we were to look at that on Desmos, we would be able to find that point as well. Hang on one second, I'll plot it. -5x squared plus 25x plus 1. We see that right there is the x-intercept, 5.04, 0. We're going to rely on the technology to do it for now. We'll learn how to do it by hand later on. All right. That actually brings us to the end here. We're just going to look at the summary together real quick, and then I'm going to have you practice something, just something small. So a quadratic equation can be written in standard form. We're familiar with that. A quadratic equation can have 0, 1, or 2 real solutions. We saw that, remember, that it can cross. Let me give you an example of that. Let's go ax squared plus bx plus c. And right there, that parabola has 0 solutions. This parabola has 2 solutions, crosses the x-axis twice. This parabola right here has, right there, 1 solution. Algebraically, we can solve an equation that's set equal to 0 by finding those places where the graph touches the x-axis. We can do it with a graph, or we can do it with a table. When we're looking at a table, we're looking for where are the y values 0. Honestly, the graph's going to be the best method, which is probably what we're going to rely on. All right, that's all for today. Thank you.